What I would hope motivates a high school student is sort of the idea that I can change something, right? I can really have an impact by helping to change how we do things. You were the kind of kid who always took the clock apart to figure out what makes it tick. That's the kind of mental mindset that really makes a good engineer. Trying to understand what is behind it. Why does something work? Why does it work the way it works? And I think it's exactly this adaptability of chemical engineering. It's such a fundamental, deep and broad at the same time education that you get as a chemical engineer, that you're really prepared not only to help run the industry as it exists right now, but really form new directions, new ideas, and really push the future. So I really deeply believe that chemical engineers have a major contribution to do for future industry.
So you may have heard of chemical engineering before, but what does a chemical engineer actually do? Chemical engineers apply the principles of math, physics, and chemistry to develop and design manufacturing processes. Chemical engineers are employed in almost all industries, including food, polymers, chemicals, pharmaceuticals, materials, and electronics. But one of the most important roles that a chemical engineer can play is in generating energy. Energy that powers everything around us, from our homes to transportation. This energy is typically created through different types of fuel. One of the ways that chemical engineers create energy is through fossil fuels. Fossil fuels are the world's primary energy source and are formed from organic material over millions of years. Burning fossil fuels such as coal, oil, and natural gas releases massive amounts of energy that can be harnessed to generate electricity and power vehicles. Oil is the main fuel source for transportation. It is extracted from underground reservoirs and sent to refineries to be processed into fuel, gasoline, petroleum gas, and other products. That is where chemical engineers come in. Chemical engineers work to design and maintain oil refining processes to make sure that everyone in the world is supplied with the fuel they need. They make sure that fuel can be produced quickly, effectively, and at a low cost. There are pros and cons to using fossil fuels. Fossil fuels are cheap and available globally. In addition, they are an efficient power source for anything that requires energy. Oil refineries are also easy to set up, and occupy less physical space than alternate energy sources such as wind farms. These refineries also generate thousands of jobs. However, fossil fuels cannot be restored once they are used. They contribute to air and water pollution, which leads to health and safety implications. They also lead to high environmental accident rates for events such as oil spills and mine fires. Most importantly, they are wildly unsustainable due to the ever-growing energy demand from around the world, and it's up to chemical engineers to find alternate energy sources to meet these demands.
Since there are so many cons to fossil fuels, what are some sustainable alternatives? Some alternatives to fossil fuel energy include solar energy, which harnesses energy from the sun, wind power, which collects energy from the wind, and plant-based fuels known as biomass. But one energy source that has gotten a lot of attention recently is hydrogen. Hydrogen is the simplest and most abundant element known. Commercially, about 10 million metric tons of hydrogen are produced each year. It is an energy carrier, not an energy source, and therefore can deliver or store energy. Because of this, it has a very high energy content and can be used in fuel cells to generate power. Here's a quick animation of how a hydrogen fuel cell works. Hydrogen splits into protons and electrons. The electrons flow to create electricity like a battery. The protons flow across a membrane to react with oxygen to create water, thereby creating no harmful byproducts. Because of its product emissions, reliability, and sustainability, hydrogen fuel cells are a good, clean source of energy. That's why chemical engineers are continually researching how to utilize hydrogen fuel cells over fossil fuels. Many students studying chemical engineering are also working to see the benefits of using alternate sources of fuel. From the University of Pittsburgh, the club ChemiCar works to create a shoebox-sized car that runs on alternate sources of fuel. This year's source of fuel is, you guessed it, hydrogen fuel cells. In order to use fuel cells to power their car, The students must create their own hydrogen gas using these reactions and an electrolyzer shown in this picture. To learn more about this process, we sat down with a member of ChemiCar.
So our club is made up of about 30 people from a variety of engineering and science disciplines, and our goal is to build a shoebox-sized car that runs and stops solely based off of chemical reactions. So we always have a propulsion mechanism that's based off a chemical reaction and a stopping mechanism that's based off of a chemical reaction. And our goal is to take this shoebox-sized car with these reactions that we've developed and run it at a competition where it has to go a distance of between 50 and 30 meters carrying a certain weight of water and stop at a specific location. So we vary this by changing the amount of concentration of chemical that we add to our stopping mechanism, which directly affects the time it takes the car to run. We'll brainstorm a bunch of different reactions. So for example, for propulsion, they're usually pressure-based reactions or battery reactions. So either you're generating pressure to run the car or you're building a battery to run the car. And so we'll usually look at different reactions that we've done in the past and things we can kind of vary a little bit to make it new for the new competition, as well as some new ideas. This year, the one thing that we're kind of doing is we're actually using a hydrogen fuel cell. So we did purchase the fuel cell, you're allowed to do that, but we're generating our own hydrogen using an electrolyzer that we made ourselves. And we use water and sulfuric acid. We run a current through the electrolyzer, and that actually is able to produce hydrogen gas from that reaction. And then we store this hydrogen gas in the balloon. So that actual contraption is not located on our car. We'll do that in like about an hour time frame before the competition. And then what we'll do is we'll actually transport this balloon, which does contain the hydrogen, onto the car and attach it to the hydrogen fuel cell. So when we put it on there, we actually have piping that connects it to the fuel cell and a valve. And whenever it's time to start the car, we'll open the valve, which will allow hydrogen to flow into the fuel cell. So hydrogen is the fuel, and it also lets air in, and the product streams are actually just water. So that'll run our car for us. The further along I've gotten in my academic career and the more I've learned, the more background I've been able to apply. And I think it's really nice that we have people from a variety of different stages in their chemical engineering degree, because everyone has something different to offer.
Clearly we are at a precipice where things are changing significantly from the fossil fuels based industry that is the oil and gas industry of the 20th century that really has helped to build the affluence and the high standard of living that we're enjoying nowadays, to something that is more sustainable. And clearly there are issues with using fossil fuels, and we see an emergence of much cleaner solutions across the fuel and power spectrum. In the fuel area specifically, again, biofuels and bio-based processes overall are clearly an emerging technology that is again at the core of chemical engineering.